So good morning to all of you. Our today's topic is gears. First, you should know what is a friction wheel. And you can see two wheels, both are in contact together. So you can imagine when the larger wheel rotates, what happened to the smaller wheel? It will also rotate. And also note, when larger wheel rotates in clockwise direction, smaller wheel will rotate in counterclockwise direction. So this is an arrangement used to transmit motion from one to another. How it works? It works on friction between the two wheels. So, but there is a disadvantage for this type of wheels, because at high speeds slipping of wheel can occur because of the higher forces slipping can occur. So that is a disadvantage, and friction wheels also cannot be used in such situations. Therefore, they modified friction wheel such that they provided teeth on the periphery of friction wheel. Now you can see two circles with the dashed lines. They are representing the same friction wheel. Now you see what people done are they cut teeth on both wheels such that the contact will be now transferred to the teeth, and due to that contact, motion is transmitted. This is the gear. So very simply, a toothed friction wheel is gear. Otherwise, a friction wheel with the teeth cut on its periphery is gear. Next, classification of gears. First, according to the position of axis, what are the different types of gears? They are parallel, non-parallel but intersecting, and non-parallel, non-intersecting. Now see, parallel gear means the axis of rotation of gears will be parallel to each other. An example for such type of gears is spur gear. It's a very common type of gearing, spur gearing. Now here you can see an example. This is an example for parallel system. Why it's parallel? You see, the axis of the larger wheel is this one, smaller wheel is this one. That means they are parallel. Okay. Next type, non-parallel intersecting. An example is bevel gear. Here you can see the axis will not be parallel, but they will be intersect at one point. So this is the axis for first wheel, second one is this. So they are intersecting at a point. And finally, the third type is non-parallel and non-intersecting. So why it is non-intersecting? Now you see this example. Here the axis is vertical for the bigger one. For the smaller one it is horizontal. But they are not in the same line. They are offset by a distance, so that they will never meet. So such type of gearing is called non-parallel, non-intersecting gears. Clear? So to note all these things, first you have to note gears, then you have to get subheading friction wheel, then draw that diagram and write about what is friction wheel, what it is used for, then write what is a gear, then classification of gears. First one, position of axis, you have to note down all this. Now another classification is according to the velocity of gear. That is simple, low, medium and high. Usually when the velocity is less than 3 meters per second, we call it as low velocity gear system. When it is 3 to 15 meters per second, it is medium, and above 15 means we consider it as high velocity system. This is another classification. And finally, one more classification according to the type of gearing. You can see the both diagrams in this page. In the second one is a normal gearing system, but first one you see there is a change. How it is connected? The one wheel is connected to the interior of the other wheel, internal teeth of the other wheel. That is called internal gearing, and the other type is called external gearing. So what's the difference between internal and external gearing is, when you use external gearing system, the motion transmitted will be in opposite direction to the driving wheel. But in case of an internal gearing, you can assume both the driving and driven wheel will rotate in same direction. This is another classification, so note down these also. Then next is gear terminology. Okay, let me take some break for 2 minutes. Now you see gear terminology. So you have to write all these. There are some 20 terms you have to familiar with. So all you have to write down. First one is pitch circle. Now what is pitch circle? Pitch circle is simple. Just imagine the friction wheel from where the teeth is cut or gear is formed. In case of friction wheel, that circle corresponding to the friction wheel is called pitch circle. So it will be an imaginary circle on a real gear. It will be an imaginary circle, and that is corresponding to the friction wheel from which the gear is made. So where is the pitch circle here? You can see 4 arcs in this diagram. So probably which one will be the pitch circle? This is the pitch circle. Clear? This is the pitch circle. Similarly, the mating gear will have another pitch circle with coming like this, such that it will meet at only one point. And that point, imagine, is the same as the friction wheel, and that point is the next term, third term, pitch point. The pitch circle meeting at a common point is called pitch point. And pitch circle diameter is the second term. That is very important quantity for calculation. Pitch circle diameter, it is represented using capital letter D. Okay, please note down pitch circle diameter always representing in millimeter and using capital letter D. Now fourth one is addendum. Addendum is the radial distance between pitch circle and top of the teeth. Okay, note down, is a radial distance between pitch circle and top of the teeth. Similarly, in the next one, dedendum is the radial distance between pitch circle and bottom of the teeth. Now here I will show which one will be addendum. This is pitch circle, and where is the top of the teeth? This point. So this distance measured in radial direction, this distance is addendum. Okay, addendum. And from to the bottom, this distance is, sorry, some disturbance, wait. Okay, so this distance is dedendum, sorry, not this distance, up to the bottom. Okay, this is the bottom, otherwise here this distance is dedendum. So this to the top, the distance is addendum, and this one is dedendum. Okay, please note down. Now you can see an arc passing through the top, so that is called addendum circle. Similarly, and one passing through the bottom is called dedendum circle. So 6 is addendum and dedendum circle. So note down all this. Then we'll come to another one, circular pitch. Circular pitch is another important quantity for calculation. It is actually the distance of a point on a teeth. For example, take this point on a teeth to the same point on the next teeth. Clear? Point on a teeth to the same point on the same position to the next teeth, measured in along pitch circle. Okay, measured along pitch circle. That is called a circular pitch. Clear? So you can write like, it is a distance measured along pitch circle from a point on a teeth to the same point on the adjacent teeth. It is represented as PC is equal to, mathematically it is equal to pi d by t. Okay, write again. PC equal to pi d by t. So note this, put it in a box. D is the diameter of pitch circle in mm and t is the number of teeth on the gear. Clear? The next is diametrical pitch. Diametrical pitch is another mathematical term which is actually the ratio of number of teeth to the pitch circle diameter. The ratio of number of teeth to pitch circle diameter, that is T by D. This is called diametrical pitch. Note down that also. And use PD to represent diametrical pitch. Next is module. Module is another important quantity. Module is defined as the ratio of pitch circle diameter to number of teeth. Okay, simple. Pitch circle diameter to number of teeth, that is reciprocal of diametrical pitch. And module is represented with letter M. M equal to D by T. And remember D in mm, diameter in millimeters. Then we will continue gear terminology. 10th one is clearance. I will take a break. Okay, next one is clearance. So imagine two gears in mesh. So when two gears meeting each other, what will happen? The top land of one teeth is supposed to meet the bottom land of the other teeth, right? You can just imagine. So there people will provide a clearance to avoid expansion and all. They will provide a small distance between the top of a teeth and the bottom of the meshing, top of a teeth of a gear and bottom of a meshing gear. That is called clearance. Now in this diagram, you can see that an arc passing through here. This is the clearance circle. Clear? So clearance is that distance from bottom to that circle. That distance is clearance. So how you can define? You can define like the distance between the bottom of a teeth, teeth of a gear and top of teeth of a meshing gear. Then next one is total depth and working depth. So what will be total depth? That you have to imagine. Total depth means from the bottom to top. So what is the distance from bottom to top? You have to mention in terms of addendum and dedendum. So from bottom to pitch circle is dedendum. From pitch circle to top is addendum. So addendum plus dedendum. That is the total depth. Please note down. Then what will be working depth? From the previous definition you have to tell. Working depth will be total depth minus clearance. Clear? Total depth minus clearance. So note down that also. Next, tooth thickness and tooth space. So tooth thickness is thickness of the two teeth measured along pitch circle. Okay, that is important. Thickness of the teeth measured along pitch circle. If you measure it here, that is smaller. That's not correct. That's wrong. Should measure along pitch circle. That is a width of the tooth. Then tooth thickness. That is a tooth thickness. Okay, not width. Width is called a tooth thickness. Then next is tooth space. Tooth space is distance between two teeth measured along pitch circle. Same thing. Distance between two teeth. That gap is called tooth space. Okay, next is face and flank. Actually, face is nothing. The surface of teeth above pitch circle or above pitch surface. Pitch surface means you can see a line corresponding to pitch circle here. Okay, this line. So this imaginary plane is called pitch surface, and above pitch surface, that surface above that is called face. That means, I'll tell you, this surface is face. Similarly, this surface is face. Similarly, the other two sides also. That is called face. Clear? Then what is flank? Flank is similar to the surface below pitch point, below pitch circle or below pitch surface. That is, see this total space, this space, etc. So below it is flank. Then we will come to top land. Top land is the top surface of teeth. Okay, see this total distance. Okay, that is top land. So then backlash. Backlash is nothing. The difference between, note down, it is the difference between tooth space and tooth thickness. Okay, so tooth space, you know, the distance between two teeth, and the other one is the width of the teeth. Both are measured along pitch circle. So backlash is the difference between tooth space and tooth thickness measured along pitch circle. Okay. Theoretically it should be 0. Then next definition is path of contact. So right, that is important. Path of contact is actually the path traced by a point of contact of two teeth in mesh from beginning of contact to the end of contact. Understood? That means in some point the ears are meeting. So if you trace the path of that meeting point, what is the result? That is called path of contact. So you can write like path traced by the point of contact of two teeth in mesh from beginning to end of engagement. That means contact. Now its length is another important quantity. That is the next term. Please note down. The derivation of length of path of contact is an important topic. Next is arc of contact. Arc of contact similar to path of contact, but it is measured along pitch circle. So path traced by a point on pitch circle from beginning to end of engagement. The only difference, it is measured along pitch circle. That's why it's called arc of contact. And finally, arc of approach and arc of recess. I will explain it later when during the derivation. Arc of approach means from the, it's such that arc of contact is the sum of arc of approach and arc of recess. But arc of approach means it is from the beginning to the pitch point. Okay, the path traced from beginning of contact to the pitch point is called approach. From pitch point to the end of contact or engagement is called recess, arc of recess. So this sum will be arc of contact. That we will explain later when the derivation is taught. So this, okay, so up to this is the first lecture. So please remember, you have to write, this is a third module, and one topic, one unit is gear. So you have to write gear, then friction wheel definition, that diagrams, then toothed wheel also you have to draw, then you have to write what is a gear, then gear classification you have to write all the 3 types of classification possible. You add some figures also. Then what else? Shortcut. Then gear terminology. Gear terminology, you have to write all these 21 terms, you have to write with the definitions. Okay, if you have any doubt in any definition or demonstration, please ask me either in personally or in Teams group or in WhatsApp group. And also there will be many issues with this video, I hope, because it's first recording. So you feel free to share all drawbacks of the video. Okay then, thank you.